40 years ago, before the days of physics engines, that amazes me. Today I'm setting myself the challenge to make asteroids under these conditions. 1. I must use SFML. If you don't know, a multimedia library is basically a way to easily control common game functions such as creating and rendering to a window. The difference between this and say Unity is that SFML is only going to help with the really low level stuff, whereas we are left to do the rest on our own, for example loading textures or implementing physics. Now because this library is pretty new to me, I'm going to start out by creating one of these little sorting algorithm visualizers that you may have seen on YouTube. Setting things up in VS Code is actually really easy thanks to this guy's GitHub repo. It has all the build tasks and such pre-configured, so I don't have to play around with any commands when I want to build. Soon enough, I got this first window rendering and loaded a sprite onto the screen. Then I got some blocks to display using this little snippet of code, and soon enough we got the bubble sort working, however inefficient it may be. At this point I'd learned the basics of the library and I was pretty confident that I could move on to asteroids. Next I encountered the first problem. Asteroids have their 0, 0 coordinate. Scaling down the player slightly, I moved on to playing around with the keyboard inputs and managed to get the console to print each time a key is pressed. I used this in conjunction with a rotate function to allow our ship to move. This worked fine, but you can see how the ship is sometimes faster and stuttering around. This is because the game currently has no delta time. Delta time allows us to move stuff independent of the frame rate. So what that basically means is, let's define some speed variable and set it equal to 10. If our game is running at 5 FPS, this means in 1 second we will move 50 units. However, if our game is running at 60 FPS, we'll move 600 units a second. This is an issue. Let's try fixing this by multiplying our speed by the time since the last frame. Now a game running at 5 FPS will travel 10 units per second, and a game running at 60 FPS will travel 10 units per second. This time since last frame is delta time, and it's what we need to solve our bug. This was surprisingly easy to implement though, and I got it working pretty quickly. And there we have it, smooth rotations. Next up is movement towards the direction of the player's rotation. I'm not going to explain how this is the basics. This was by far the hardest thing to implement, as I'm pretty much coding the physics by hand. The approach I went with was to have a gain value that increases when holding forward and decreases otherwise. The gain value increasing worked like a charm, however the decreasing or drag of the ship was incredibly frustrating to get working. Normalization came in clutch though, and I have to fix the velocity as a met, basically when then this bullet moves based on the ship's direction when it was fired. This is then set in the constructor. I did have a little bit of trouble at one point and made this though, and I genuinely could not recreate this if I tried, so kudos to the bullet class. This was kind of a wake-up call though to how messy the code was, and I decided to spend about an hour rewriting everything so it was object oriented. Anyway, here's the bullets working.
Given the fact that there are very few tutorials for you to learn Unreal Engine and C++, applicable items, I'm going to detect collision, and I'm going to do all of this cool stuff, everything using C++, because there is very little, almost none C++ tutorials using Unreal Engine. I want to fix that. So we can move, we can jump, and all the good stuff, but I want to create this from scratch because I want to show you, I want to explain. Include over here that you include anything else that you need. So here I'm going to say include, and for example we need, one of the things that we need is a camera, and over here I'm going to say camera component. If I were to use this and I include it below, it will not even allow me to compile. So over here I'm going to include below, Control Shift B to compile it, or you can go here under build and click on build solution and wait for it to compile. You will see automatically it has failed, and even here it will tell you on line 11 in the batteryman.h file you have an error, include found after dot generated h file. So it's not allowing you to include anything after the dot generated h file. Make sure that you memorize that, or otherwise you will have issues, and there you go. So I'm going to include everything that I need before I proceed to do anything else. Except for the camera, I also need components, so components and slash over here. I also need the capsule component, and here make sure that you end the quote, so include next, so it's include and in quotes. I also need components and slash, and this one is going to be the static mesh component. Also hashtag include, And in quotes, we are also going to need components slash, and this one is going to be input component. We also need slash, or actually hashtag include, and over here, game framework, so game framework, and inside of the game framework, I need the character movement component. There you go. We also need an include. I know it's tedious to do this, but we need to do it. So it's game and bring. I think that I'm right. If you don't know what a constructor is, please watch my C++ tutorial series, which you can find here on YouTube. Simply type Awesometube C++ tutorials and you will see that. So a constructor will allow us to create an object out of this class. So this is the constructor, and right here below the constructor, we are going to have a U property, and it is going to be visible anywhere. And visible anywhere basically means that we will be able to see it over here. If I, for example, select, I don't know, let's say this cube over here, and it's not important what I selected, but it's important over here in the details panel. This is the details panel right here. So over here in the details panel, we will be able to see the variables that we mark with visible anywhere. Now I'm also going to say here blueprint, so blueprint. What is up, guys, and welcome to a new mini course. Well, a mini course, it's 7 hours. You select the player, you will notice here at my right side, I have the inspector panel. If you are on the default layer, you will also see on your right side the inspector panel. But from now on, I'm going to switch to my layout, and I'm going to use all these tabs from my layout. But they're the same tabs, just on different position. So when I click the game object player, you will see the inspector panel or tab on my right side. Here you will see every component that is attached on that game object. Since I have created an empty game object, which is a default one, you will only see transform. But later on in the game, we will see sprites, which are representing 2D game objects, which are basically image renderers. So sprites are, or sprite renderer are image renderers. So if you have a character, that sprite render will render it, basically draw it on screen, same as from the image. You will also see rigid bodies, which simulate physics. You will see colliders, which helps us collide or help two game objects collide with each other. You will see audio components, which will allow us to play sound, and so on and so forth, but that will come later on. And basically you simply click on add component and filter for it. For example, if you want a rigid body, here it is. If you want a sprite component, here it is. You simply type sprite, and here it is, sprite renderer, and so on and so forth. So all of the information about the game object and its component, you will see in the inspector panel. And you will also see scripts that are attached on the game object, because scripts are also components. Moving forward, here you will see the project tab, and this is at my bottom left corner. So the project tab will show you all the folders and files you have in your game. Currently, by default, we have this scene folder, but we can right click, we can create a new folder over here, and I can name it, for example, scripts folder. I can name it prefabs. Prefabs are saved game objects. We will come to that. Don't worry about that. We can save audio files, fonts, UI images, and all of the good stuff. Everything will be available here in the project tab. Now, one thing about the project tab is remember to keep it organized. You saw me create a folder for scripts. Same way you will see me create a folder for my images, for my sounds, for my fonts, for my prefabs. Moving forward, here at the top left corner, I have the scene tab. So the scene tab, which is this right here, is basically the game in Unity Editor. That means every game object I put inside, I will see it in the scene tab. For example, here is the player game object, and I can click here on the player game object, and in the inspector panel, I can click on this cube over here, and I can give him an icon. And there you go. So now he has an icon, and this is in the scene tab is where you are going to position your game objects, your UI elements. It's bound the camera, by the way, where he is that. Over here, behind game tab, you can add a desired resolution for your game. So when I click here, full HD, and for some reason I have it full HD, it is going to change the scene over here, how we see it. I mean that. Click on the full HD portrait. And I'm going to see now that we see the camera games for full HD portrait. Set here to mobile later. I'll show you for what is the game tab and builds. So currently it's for PC, Mac, and Linux standalone. If you want for Android, you're going to click on Android over here and click on switch platform. It is going to take a few moments depending on also how large your project is. So if you have, a lot of assets and game objects, you progressed a lot in your project, and for some reason you need to switch platform. This happens when you develop for Android and iOS as well. Then you will wait a moment or two for all of this to compile and, yada, yada, yada. So that's basically it. So now if I go over here, I have more. You can click on the plus button. You can give, and there you go. Here the project they will be displayed here in print statements or inside of the console tab. Now this console tab is pretty good, but there are also better ones on the asset store which give you more information to speed up your development process, but as time goes that will come, so don't worry about that. Let's get into the juicy stuff. Over here, I have a game character, and if I double click it, this is what you see. And this is a nice little one-eyed, fluffy thing, which is a character from my game called Gravity Control. And this right here is called a sprite sheet. Why? Well, because we have multiple characters, basically multiple images inside of one image, and this will form a blink animation inside of the game, which we will see in a moment. But on its own, this is the character, and you can either import him like this, or you can import him like a sprite sheet. Why do I import him as a sprite sheet? Well, because this is more efficient memory-wise and performance-wise, because you have all of the characters inside of one image, and then you import them in your game and you slice them up. That means choppa, choppa, choppa. So let's see how that works. First things first, over here in the assets, remember by the organization, I'm going to right click and create a new folder, and I'm going to call it sprites folder. Of course, further on in the assets, you can subcategorize. So over or UI element, where I am going to import my character. How does the plus button, and voila, here is our character inside of the game. Now I can, as I said, I can simply drag him like this inside of the scene. Remember, the scene is where you form your game, where you arrange elements and characters and all of the good stuff. So I can put him over here, and that's it. I can go here in the game tab, and remember, game tab shows you how your game looks like. And not corner, but something that you want to have in your game. Vector game command delete or delete button on Windows. Now, one thing I'm going to explain before we go, notice over here we have a sprite render component attached on that game object. In order for Unity to render this image, we need a sprite render component, and over here we provide the sprite that we want to render, which in this case is this character. So this is one component that I talked about, and this is how it works. So I'm going to delete it now, and I'm going to click it because you're probably wondering, okay, teacher, you are crazy. I'm not going to use this in my game. And I know I am crazy, and I know you're not going to use it in your game like this. You want to use every different element of this sprite in your game. How can you do that? When you are in the sprites folder, you are going to select your character. From there, when you select it, over here in the inspector, you will see the properties of that sprite. And you will see something called sprite mode, which is currently set at single. What you can do is you can click on that drop-down list and change it to multiple, and then hit this apply button over here at the bottom right corner for the inspector of your sprite. When you click apply, it applies that change, and then you can click on this button here called Sprite Editor. When you do that, now you see your sprite over here, and what you can do is you can slice it up. As I said, you can choppa, choppa, choppa. So we can, slice it into parts like this, and then we can use every individual part from this sprite. And in order to do that, I click the slice button over here. There you go. And click on it, and over here we have the type of slice that we want to do. We can do an automatic, which will allow Unity to automatically slice all of these sprites, which Unity does a really good job at, by the way. And we can also click on the drop down list and we can, do it by, we can do it grid by cell size, which basically means we are going to set our own pixels and offsetting and so on and so forth. Don't worry about that now. That will come later on. This is basically for images that have the same width and height. For example, 512 by 512, or I don't know, 1080 by that. But when you set on automatic, thing we need to do characters. So over here, you can see it sliced. You see over here, we have character 1_0, then character 1_1, so on. A sprite sheet happens to know which is the when you are using it in your game. That's the wisdom behind the renaming. Over here, we don't have to do anything because, it's a character. It simply slices it in parts. We can probably say character 1, 2, 3, 4, 5, and yada, 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 but we don't have to do that. When we are done, you can also, by the way, if for some reason, and sometimes Unity does this because, as I said, it does a pretty good job at slicing all of these, but sometimes it will miss, and maybe you will see this over here. So it's not on your game object wholly. So it's not circling your game object. What you can do is simply, change these. You can move them and you can, position them over here. You can zoom in to see where you're going to position them so that you position them correctly. There you go. And over here as well, we can do that, so on and so forth. So you can, you can correct the errors that Unity has done, but that rarely happens. It depends on your image most of the times, but as I said, that rarely is right here. Here is the apply button. So over here, click on it, and there you go. Which means now I can go back over here and I can use all of these characters on their own. So now you will see when I go in the game tab, we have a single character as opposed to having all of those characters at once in our game, same as we had, a moment ago. So this is how we can separate individual sprites from a sprite sheet and use them in our game. Of course, if this is a game we are creating, not an example that we are currently going through, we will add a rigid body, we will add all of those components. Don't worry about that. That will come and that will form a game object, or that will form your character in the game. One thing that I want to point out before we continue is that you can have all of these images separated. So this can be image on its own, this one can be an image on its own, and you can import them as 3, 6, 8. So we have 8 images over here. You can import them as 8 different images. But as I said, when you put them here in a sprite sheet, that is more efficient when it comes to memory in your game, when it comes to performance and all. I had to say that to you. And then you would first, before we do that, I want to show a couple of components that we want to simulate physics. And physics, I don't have to explain it. It gives, physics to our game objects. It applies gravity to it, forces can affect it, you can interact with it, and all of the good stuff. And in order to do that, as I already said, you simply go here, select the game object inside of the hierarchy panel, because if you remember, when we introduced the hierarchy panel, it represents all the game objects in your game. When you select the game object that is in the hierarchy, here in the inspector panel, you will see all of the component and properties that are attached to it. Currently, we only have the transform, which is the default one. We saw that, and now we have the sprite render, and we already explained that. So next, we are going to click here on add component, and here in this little search bar, you can filter for rigid body. But you can also do this. You can go over here and you can filter for these options that you have. So over here we have physics 2D. You can click on that, and here you see all of the things that we have, but usually you are going to type here in the search bar because it's a lot faster. So simply going to type rigid body. Now, one thing that I want to point out that is, you will see over here, and well, it went away since I took my annotation. Anyways, you will see here we have a rigid body and rigid body 2D. That rigid body 2D is self-explanatory, but rigid body is for 3D. I don't know why they didn't put rigid body 3D and rigid body 2D, but anyways, 2D is for 2D games, 3D is for 3D games. So if you're creating a 2D game, don't confuse and put a rigid body, which is for 3D, on your game object. So I'm going to select rigid body 2D, and that's all there is to it. Over here, you will see on the rigid body, we have a few options. So we have the body type, which is dynamic, kinematic, and static. I will talk about that in a moment. We also have over here for the mass, we set the auto mass, we can set it on our own. So currently it's 1, or by default it's 1. We can set it at 1000, whichever number we want. Linear drag, angular drag, gravity scale. Basically, gravity scale is, how much gravity is applied on our player. If we set that to negative size or negative value, it will draw the player up. So it will move him up and not down, because we know gravity pulls you down. So over here we also have constraints. If we want to freeze the position for X and Y and freeze the rotation for the Z, so that will not allow our character to rotate and move and so on and so forth. We will explore this. You'll notice that, there you go. You see that our game object fell, and it's over here, so it's falling down. And why is that? Well, because we applied a rigid body on it. It pulls him down. It's gravity, as I already said. Now, in order for us to land on something, we need to have a collider. And for that, I'm going to right click over here and create an empty game object, which I'm going to call, I don't know, ground collider. And even though it's an empty game object, we can still attach a collider on it. So we can select it, and we can go here in the inspector, and we can filter for collider, and I'm going to select box collider 2D. So you can see the shape is a box. If I select it, it's a box. And over here inside of the inspector, you have options. So we have the offset. You see, this is offsetting the box, even though it's not moving the game object from its own position. You have the size. So if I resize it, you will notice now the box collider is bigger. One thing that I want to point out is that in the scene view, because we are laying out our game objects, we can see this box visually, but in the game we don't see it. You see, in the game we don't see it. If I hit the play button, we will notice now that again our character fell down. And now you're going to think that I'm crazy, and you're going to be like, teacher, but you said it's not going to fall down. Listen, I know I'm crazy, but that's another story. But as I said, we need a collider. And we need a collider for our own game object as well. So no matter if it has a rigid body, if it doesn't have a collider, it will not collide with a collider. So even though this ground is right below our character, this fluffy thing, we also need to select it and go over here, and we can filter for colliders, and we have something called a circle collider 2D, which is going to, you see, be a circle or circle it around. Now, which colliders you want to apply will depend on the shape of your game object. So if you have a cube or something that is similar to a cube, you're going to add a box collider. If you have a circular game object like this one over here, you're going to apply a circle collider. So over here, I'm also going to change the radius, because we have a lot of options here that I encourage you to play inside of the inspector panel. And that way you will learn faster and more efficient and better. I'm just showing you examples over here, but when you play with these, you will notice what is going to happen. So now if I hit the play button that we have attached the collider on our character, bam, you see now they are standing on each other. And here is our character, and if you look at here, he is standing on an invisible ground. If I select the ground collider over here, you will notice, and for some reason it is not showing up, here is the ground. Where is the ground collider? Here it is. For some reason it didn't show it right away, but anyways, you can see that he is standing right on the collider of this game object. And if I select the character as well, you will notice how their two colliders are overlapping with each other. Of course, in the game it will not look like this. You will probably have a ground, so it will similarly look something like this. So he will be standing on some type of ground, which is also a sprite component as well. Now I want to show you another thing, and that is when I select the character over here inside of the collider, you will notice one thing. We have something over here called is trigger, and it's a checkbox. What will happen if I check that checkbox? Well, let's find out. I'm going to hit the play button, and now again you will see that my character fell through the ground collider, even though it has a collider. So what's going on? Teacher, again you said, don't cry, don't panic. I'm going to uncheck the is trigger. Basically, later on in the code, we're going to see how we are going to detect these collisions between game objects, because this is currently a ground, but imagine it to be a collectible item, a coin or a health item or whatever. We need to know when these two touch each other inside of our game. And in order to do that, we are going to use code. Now, one of the ways to know that is by checking this isTrigger checkbox, which is over here. And later on in the code, we are going to use something like onTriggerEnter. It's a function that's called onTriggerEnter that allows us to detect which game objects have collided with which game objects. And a trigger collider is not a solid collider, as you saw a moment ago. It can pass through other colliders, but still detect collision. Why am I showing you and telling you this? Well, because imagine you have a collectible item. You want it not to be a solid collider. You just want to, collect it, and there you go. You don't want to hit it and be bounced off it or something like that. So for that, we're going to use trigger colliders. But don't worry about that. We will see it with real world examples later on when it comes in the game. Next on the menu, we have the audio source, and I removed all the components that we used previously. And if you're wondering how you can remove a component, so for example, if I have a box collider over here, you are simply going to click here where are these three dots on the component itself. As you can see over here, these three dots. When you click on them, you will see this remove component, and voila, that's all there is to it. Next, I'm going to click on here, add component, and I'm going to filter for audio source. And this is a component that will allow us to play music in our game. Sound effects and all of the other stuff, of course. Now, as you can see over here, we have one thing which is audio clip, and it says none because we didn't attach any. The audio clip is your MP3 file, WAV file, whatever file that plays audio sounds, and you attach it over here, and then this audio source will play it. You have other options over here, of course, to mute. You have options to play on awake, which means as soon as we run the game, it will start playing. We have loop to loop it over and over again. You have over here the volume, the pitch, and so on and so forth. You can play with these, and these all are accessible via code. And most of the time, we will play these via code. Now, as an example, I have one sound effect over here, and I'm going to select the character. And by the way, I have attached this audio source on the character, but you can attach it on whatever you want. You can attach it on your grandma if you want that, okay? Just kidding. But anyways, you can attach it wherever you want to attach it. You will have probably a game object called BG Music, sound effects, or whatever, and you will attach the audio source components on them. And if I drag now this piano audio clip and I put it over here, if I run the game, but before that, let me just lower the volume a little bit so that we don't, go deaf. Here we go. So this is playing audio in our game, and this is also if the game is run on a device, mobile, desktop, no matter what, or which device, it will be played the same way. Of course, as I said, this can be controlled via code, where we write code, audio source.play, stop, and so on and so forth, and it will play and stop this audio sound as well. So I'm going to remove this component, and before we, go into the nuts and bits of coding and all of the good stuff, I want to show you another common component that is used all the time, which is UI elements. And if I right click over here, you will go under UI, and then over here you have the UI elements. You have the text, you have the text mesh pro, I cannot pronounce, I don't know how to speak. We have the button, we have the image. So let's start with the image. I'm going to click here. Now, one thing you will notice is you see this big thing now over here, this big rectangle, whatever it's called. That's the canvas. And the canvas has its own options. You can see over here, when I clicked on the image, it automatically created a canvas because every UI element needs to be a child of a canvas. And it also created an event system, which is responsible for detecting input on UI elements. Now, the canvas has a few options over here. For simplicity, because we will talk about that later on, for simplicity, I'm going to select the canvas and change this screen space overlay to screen space camera, and I'm going to attach the main camera over here just so that we can, make it a little bit, smaller, because it's easier to interact with a smaller canvas just because of the visuals. Anyways, this is our image, and you will notice it if I select the image, and I can move it left and right. If I can select it first, I can move it left and right, up and down, and you will notice it wherever I move it, it will be present here inside of the game. Of course, we can select the image, and over here we can attach a sprite. So let's go over here inside of our sprites, and over here I'm going to drag, I don't know, let's say character 1, the same one we have over here. And I can click this set native size, which will set the native size width and height, which you can see over here. Width is 150, height is 119. And you will notice it. This right here is our UI element on the left side, and on the right side is our game character. And of course, this is our own character. You can use it, for example, we can position him over here at the top left corner, and he will be used to represent health status or whatever. Same way, this can be a coin representing how many coins we picked up, and so on and so forth. You get the point. We can also create a button. I can right click over here and we can go under UI and we can create a button, and voila, there is our button. Our button can be also resized, so we can do something like this. We can resize it. We can select the text which is inside of the button. We can say, for example, play game or something like that, and I can, resize it over here. There you go. If I hit the play button, we can press the button. If I hit the play button, we can press, and you will notice it is blinking, which is indicating that we are pressing it, and I'm currently pressing it. And I'm pressing it with the mouse button, but same way, you can press it with your finger on mobile devices and it will work the same. Of course, later on, we will see how we can execute functions and code when we press a button. Now, another UI element, and that is going to be the last one that I'm going to introduce over here, is a text. Now, we have a text and we have Text Mesh Pro. We will talk about both, but currently I'm just going to show you the text one, which is a simple text. You can, move it left and right. We can resize it like this. There you go. We can, over here inside of the inspector, we can type whatever we want, whatever I want, and I can, change the color, the font over here. You see, we have some fonts. Actually, we don't, for some reason. Yeah, we have only the default Arial one, but we can import our own fonts, whichever font you find online, of course, that is permitted to be used commercially, or if you buy it. And over here, you can set it to be normal, bold, italic. If you use any text editor, you know what I'm talking about. You know what this is. And since you're on a computer, you probably used one. Over here, you can change the color of the text. So, for example, we have it to red one, and you see whatever I want. And this is how we are going to represent text in our game. For example, how many lives we have, how many coins we picked up, what is the current score, so on and so forth. So these are the three most common used UI elements. Of course, we have many others. So over here in the UI, you see we have raw image, button, toggle, slider, drop down, input field, and all of the good stuff. But I wanted to cover the most used components in these 2 or 3 videos, which are rigid bodies, sprite components or sprite renders, audio sources, and these UI elements. So these are the most used ones, basically the components you cannot create a game without. So yeah, this was a brief introduction to those components, and later on in our game, when we start creating things, make it interact with each other, we will, introduce them in more depth, use them via code, and all of the good stuff. Okay, so now we're going to get into the scary part and create a full game in 2 minutes. And I'm just kidding, of course. We're just going to go briefly and see what scripting is. But before that, when you download Unity, you also downloaded Visual Studio with it. So just make sure over here under Unity and Preferences, this is for Mac. For Windows, it's Edit and Preferences are somewhere over here. But you are going to go under Preferences, and let me just open this window nicely. So there you go. Here you have external tools. Here it is, Visual Studio for Mac. So there you go. And if you do not see it by any means over here, you can click on Browse and you can locate your app and just, select it. For example, I can go in Applications, and from here, I can find Visual Studio or whatever. So here it is, and click on it, and there you go. So do the same thing for Windows. Just make sure that external scripting or script editor is your Visual Studio. You can also use Visual Studio Code, but that is your own preference. So going back over here inside of my scripts folder, I already created a player movement script. And before you start judging me and telling me I'm crazy, which is something we already know, just right click over here and go on Create and click on C# script. And when you click on that, just give it a name. So script name. There you go. And then simply double click it and it will open in Visual Studio. I am going to delete this because I have the player movement and I have created it in the exact same way I just showed you. So I am going to double click it and it is going to open over here. So what do we have here? Now don't worry if you don't understand all of these things. If you don't understand what it is, and over here I just wrote class, do not worry about that. All of this here is not important that you understand it right away, because after this we are going to go into C# and learn it step by step. But what I'm going to do is I am going to create a public float speed variable, and I'm going to say that is equal to 5 by default. Why? Well, because we are going to go inside of Unity. And I am going to select the character. Remember, I told you that here, when you select it in the inspector, you see all of the components attached on that game object. Well, our script is also a component, so I can attach it over here. And there you go, we have it. And we also see this speed variable, which has a value 5, which is the one that I created a moment ago, this over here. So what do I want to do inside of this script? I'm simply going to move the character, and we are going to move it by using a float, which I'm going to say h is equal to input. So input, if I can, type it correctly, get axis horizontal. There you go. And I'm also going to say float v is equal to input.get axis vertical. What is this? Again, do not worry. It's not important that you understand everything right away what it is. But basically with input, we get the input from the user. Get axis and passing horizontal, that means we will get input for the A key. So I'm going to go over here for the A key, and I'm going to put them in a comment. A key, D key, left arrow, and right arrow. That is the horizontal input, basically moving left and right. And the V key is exactly that. Up and down. Vertical is up and down, W and S key. So now what we can do is we can get the position of our character. We can say vector3 or vector2 position, which is, so I can say POS is equal to transform that position. Transform that position is basically, and again, it's not important that you understand it right away, but I'm just telling you how things are connected. So if I go back over here, notice that we have our transform, which is our default. We know that it's our default component attached on our game object, on every game object that is. So it has a property position, rotation and scale, and we're using the position, which is going to tell us the position of our character inside of the game. So next what I'm going to say pos.x, so the x-axis of the position, plus equals h multiplied with time.delta time. And our position.y plus equals v multiplied with time.delta time. And then what I'm simply going to do is I'm going to say transform.position is equal to POS. And here it's not POX, it's POS. So what is happening over here, I'm getting the input. Should we go left or right, up or down? And I'm multiplying that value with time.delta time, which is basically a value or a time frame. You see over here the completion time in seconds since the last frame, basically time between every frame. And you will notice here the update function is called once per frame, which means if we have 60 frames in a second, it will be called 60 times. So we are using this to smooth things out, to smooth out the movement, and we will see of course this later on in our game. Do not worry about that. I'm just showing you basic things, how it works, so that you don't get scared, because people are usually scared because of the coding and all of the good stuff and how scary it is. So if I hit the play button now, we will be able to move our characters, you can see left and right, up and down. And also when I select him, I can change the speed variable, so I can change it to 10 from 5, and now he will move a little bit faster. Let's change it to 50, and now he will move even faster. So this is how we can change, and let's go over here, turn off the game and change it to 20 like this, because I think I was not feeling the change in the speed. Yeah, actually we need to just simply put a higher value. So there you go. So now he is going to move, let's say 1,000. So he will move faster. Anyways, this is how we can move a character. It's very simple. You can see him, he is moving inside of the game. And this is how it would look like on a real mobile device or on a real desktop device and so on and so forth. So let me just try it like this, private float instead of, so I can say private. When you set it to be private, we will talk about this, then it is not visible anymore in the inspector panel. So over here, oh, actually, this is why it didn't work, because I am stupid. We need to do this over here, 5 and then F. I need to do it h multiplied with time dot delta time, but before that multiplied with speed and then multiplied with time dot delta time. And same thing we need to do over here. So I forgot the speed variable. That's why it was not affecting the movement or the speed of our character. You see how all of this is connected. So this is how things work. So now I'm going to set the speed back to 5 and go over here. Now when we change it, it will move. You see now he is moving a lot faster. And if I set the value to 10, there you go. See, he is moving a little bit faster. I'm not even going to set it to 100 because then it will, move like crazy. But basically this is it. This is, you see, a few lines of code. 1, 2, 3, 4, 5, 6 lines of code, and we are already moving our game character with only 6 of these lines, as you can see over here. And they are not large lines like you see from the images and online and so on and so forth. But again, don't be overwhelmed. Don't think that you need to understand all of this right away. I'm just showing you how simple it is for us to perform a movement of our character the same way we would perform a jump or a crouch or a sprint or whatever. So this is how things work. Of course, now we're going to jump into C# and then we're going to learn how things work and all of the good stuff. And we will go back and forth when we explain things, what this here is, how it works, and so on and so forth. So that way everything will be clear before we jump into from the basic, before we do but it is not mandatory for you to do the same thing. I'm saying this because I did something similar in one of my other courses. People got confused, but anyways, you can create a completely new project from scratch, or you can use the one that I'm currently using to follow along. What's such as 2000 Unity. Now, but you actually click on it and design terms of Unity Hub and then go on this link, download Unity Hub. Now, if you see something different in terms of UI of the website here that you see on Unity, maybe they redesigned things, don't worry about that. Just find the download Unity Hub button, click on it and download it. When you download it, this is what you will see. But before you actually see this, you will need to log in or create an account. And that's simple, same as creating an account on Facebook, on whatever, but that is what you need to do. Now, of course, for the projects over here, you will not see anything because if it's your first time opening Unity Hub, you don't have any projects. Now, from here, how you can install different versions of Unity? Well, simply you're going to go here under Installs tab, and from there you are going to see which versions you currently have and how or download the new ones. How you can do that, simply click here on Add, and then here you will be prompted to download the versions that they give you, such as 2020, 2020.1, and so on and so forth. But if you want to download later versions, basically, versions before this, you can simply click here on Visit Our Download Archive. So when you click on that, it will take you over here, or simply type Unity Download Archive on Google and you will find it. And from here, you have versions dating from version 3 up to version 2020. And this is very important for you to do, so pay attention now. When you want to download a specific version, let's say you want to download Unity version 2022.2, then from here, you're going to click on Unity Hub. So this green button, download it from Unity Hub. Don't download it here from Windows or Mac, basically the installer. Don't do that. The reason for that is because when you click here, download from Unity Hub, and I'm going to click on Open Application, Unity Hub, open the link, and it is going to open the link right here. You will see it in a few moments. There you go. So now we are prompted to download things such as Android build support, iOS build support, tvOS build support, so on and so forth. Now, of course, you are prompted to download these same way over here if you were to download the installer. But the difference is, later on, if, for example, you're developing your game for Android, you will download Android SDK and NDK tools and the OpenJDK tools as well. So you don't have to download that separately and install them on your own and all of the, tedious stuff. So it's done for you. And plus, when you install Unity this way, then you will have it over here in your installs, and you can of course choose later on when you open a game or create a game with which version you want to download it or actually create it in. Before we proceed further on, I want to explain one thing that I want you to understand because I think it's very crucial. And I've been doing this for a few years now, and I see that a lot of beginners and even people who are beyond beginner level have an issue with this. As you can see here, we have multiple Unity versions from Unity version 3 up to 2020. Now, don't think that if you're watching a tutorial that is using Unity version 2018, then, well, you're lost if you don't use Unity 2020, if 2020 version is out. Why I say this? Because a lot of people are like, oh, and I especially see this on my YouTube channel, but this is not 2020 version or X version, whatever. The point is that the fundamental things that I'm going to teach you are never changing, so they will never change. I am using Unity since version 4, and I think it was version 4.55, or even I believe it was 5.1. So it's June from 2014, more than 6 years. So this year is going to be my 7th year using Unity, and the things I learned using this version 4.5.1, I'm still using in the version 2020. So the fundamental things don't change. They add new features, but most of the time, your game can go out with those features, except only if you want to add them for whatever reason. And even currently, I'm developing 2 games that I'm going to publish, and they're probably published from the time you're watching this video, and I am using Unity version 2019 and not 2020, even though it is out. So don't worry about that. And I need to emphasize this because later on, when you go on YouTube and you want to see a quick tutorial how to do this and that, what if the person is using Unity version 5 and you're like going to panic or stuff? No, Just follow along. If there are some differences, there are going to be small differences, but when you learn the concepts and how to use it, then you will not have an issue with that. So that being said, what I want to show you now is here. What is up, guys, and welcome to a new mini course. Well, a mini course, it's 7 hours where you will learn you.